Alright. So, you guys doing okay? Got the, yeah. That was my uncle who died, so I went to South Africa. The funeral. But, you know, it was hard for the funeral, but it was good to see the family. Yeah. Yeah, sorry I wasn't able to be here last week, but I hope you guys had some time to practice and look at the equations, and we'll get back into it. So let's start with some review. Start on page 353. Now Ahmed had some questions from the in-between tests, so I'll go over those as well. Hi, welcome. But first we'll just do the review from last week. Actually, no, let's start with the ones that Ahmed had. So I'll start with page 248. Sorry, 348.
Yes.
So you go to page 348. If you recall, I told you there's this test in the back of the book, in the middle between chapters, and it's good practice for you. So you have some extra time. I should have told you guys to try to do that in my message. But Ahmed's done it, and he has a question number 7. So I'm just going to go over that one, and we can see it. So if you look on page 348, if you guys are there, you see there's this little square, right?
Yeah.
Number 7. There's a square. It's like got 3, yeah. Over here it has 5,
Y 3.
3, and this one has 20, and an A here. And the bottom is B, D, and 9. It's like Sudoku. Have you ever played the game Sudoku? You know, they have all the numbers, and you have to match them, they have to equal up to 9.
I said you want to give it.
Yeah.
Actually.
And now you have another test.
Yeah.
Okay. So it says this is a multiplication box. Each place represents the horizontal number multiplied by the vertical number. Oh, so we have on top, sorry. 5, Y, and 3. And this one is
1, C,
1, C, and 3. Alright, so what it's saying is, each spot is this one times this. Okay? So say whatever's here is what this is multiplied. So this is 5 on top, and this is 1. So this one is 5 times 1. This one is 5 times C. This one is 5 times 3, D, okay? Here, Y1, so we could probably put Y in, if we wanted to. Here, Y times C is A. Here, Y times 3 is D. Here, 3 times 1 is 3. You just see we don't have that one yet. And 3 times 3 is 9. So each one, we basically, if we're missing a letter, we can use the box to find some things. So the question is, which of the following is equal to A? Right? The question is, A, B equals which one? Right?
Yeah.
So that means we need to look here for A and B. Alright? So first off, we know B equals 5 times 3.
Yes.
Right? So B equals 5 times 3, which equals 15. Okay, so we have that. So now we can put, this is 15A, right? 15A equals what? 15A equals something we don't know yet. Alright. And now, if you look here, we're going to have to do a few things, because A here we know A equals C times Y, right?
Yes.
A is C times Y, alright. And C, here we can get 5 times C equals 20,
Yes.
right? So we have 5 times C equals 20. So now we can solve for C, right?
Yes.
Captain, did you see this gentleman? Sure. No, it's fine. So 5 times C equals 20, so what is C?
4.
4, right? So we can divide both sides by 5, since we've learned equations, right? So therefore, C equals 4. Alright? So that means A equals CY, which equals 4Y, right? So now we have A and B equals 15 and A equals 4Y. So therefore A times B equals A is 4Y times B times 15. You guys see how I'm just putting different pieces together. It's kind of a complex problem. You have to kind of put each piece together, go with the information you have. Alright, so we have C and A equals 4Y. So this equals 4Y times 15, which equals 60Y. Is that one of our options? Yes, it is. B. You guys see that?
Yes.
Kind of go step at a time. Right? You look at this, there's a whole bunch of stuff, but they give you enough information just to go one at a time. So the first thing I did was I said, all right, what is B? I have B here. All right? The second thing is like, what is A equals these two things. I said, well, if C is Y, I can try to figure out what C is. Because I have C and two numbers, so I can figure out what C is. C is 20. And, yeah, 5C is 20, so therefore C was 4. And now I have 4, and I can put 4 in here, where I said A was C times Y. Right? So I put 4 here, 4Y. And now I have A, and I have B. I can put those two together and I get 60Y. Okay? You could fill in these boxes, but you don't actually need to. This would just be Y, and this would be 3C, but it wouldn't get you anywhere.
Sorry.
Yes. Yeah, you could say A times B equals CY times 15. But we already figured out that C is 4.
Yeah.
So it's 4Y times 15. And then when it's 4Y times 15, I'm multiplying the coefficients. So 4 times 15 is 60. So that's how I got 60Y. Yeah. Questions on that? That was a complicated one. Many steps. And just, in some ways, what this question is asking is it's asking you to think algebraically. This says you don't know the answer yet. Kind of mess with things until you get somewhere where you might have an answer. Right? So it's just this thing equals this thing equals this thing. And we keep it in its form until we get somewhere. Right? So A equals CY equals 4Y. We kind of are figuring it out until we get to a place where we have just the Y. Okay? Take a picture of that. I think the next one is like it, right, Ahmad? Yeah, so we'll do another one like this. Send that to you guys. Let's see. Oh, is that the eraser? Remove it? Okay. Alright. So I encourage you guys, if you haven't done that, those exercises, go ahead and look at them and see if there's any other things that are difficult for you, and I'll go over them like I just did now. So 51, right? Number 31.
Yeah.
Okay, so let's look at page 351, number 31.
Yeah.
All right. So we have another cube. What's on top? It's A squared.
AB.
AB, and 5.
Yes.
And down the side is
AC4.
AC4.
Yes.
Okay. and they filled out some for us.
Yeah.
So this is A,
Yeah.
and this one is 8B,
And 40
and 40 and 20. Okay? Alright, so this is the only one that's like two numbers.
Yeah.
And we'll use these things for the other stuff. So which of the following is equal to A? So we need to know what is A. Alright. So where do we start? Where do we start? One thing I can see is I have AB here and AB here, right? So I think, let me see if I can figure out what AB is, and maybe that can help me. Right? So what we have here, let's do this one. A times 5 equals AB, right? So let's do 5A equals AB. Actually, that tells us what B is, right? From this, I know what B is. Because I can divide both sides by A,
Yes.
right?
B is 5.
Divide both sides by A, and we get,
5. Equals B.
yeah, 5 equals B, or B equals 5. Therefore, B equals 5. All right. So that's a good start. All right. So B equals 5. So now let's see somewhere where we have A. I think this one here. All right.
Yeah.
So let's see, that one is going to be 4 times A equals 40.
Yeah.
Right?
Yeah.
Okay. So first of all, we can divide both sides by 4.
Yeah.
All right. So then we get A times B equals 10. Okay, and now we know B is 5, right?
Yes.
So we put 5 here. So A, I'm going to put 5 in front because I'll do it A times 5 equals 10. Okay, now we divide both sides by 5, right?
Yes. 10 equals 2.
That's right. So these cancel, and we get a 2 here. So A equals
2.
2. Is that one of our options?
Yes.
It equals A.
Yeah.
Appropriate. All right. Any questions on that? That one is actually a little bit less complicated.
Yeah, this is less complicated.
But there's more like that. So you guys go ahead and try them if you want. The other two, like, each box had 2 questions. So yeah, you guys followed how I got that? I saw here, the first thing I did was I said, okay, let's see, we have A, B here, and A. So wherever I had an A and a B, I decided to use it. There's probably some other ways you could have gone about it if you wanted to. One thought that I had as well was I could have solved it this way. I could have said 5 times A equals AB, so 5A equals AB. And then this one, 4AB equals 40, right? So then I could have done this one, divide by 4, and AB equals 10, right? And if I have AB equals 10 here, I put it here, right? So then I could say 5A equals 10. You see that?
Yes.
And then I could solve then A equals 2. That's not a good A. You guys see that? It's another way of doing it.
Oh.
An alternative way. Both ways get me to the same answer. It's kind of another way of doing it. That was how I started thinking, because I saw the 2 ABs. I thought we can probably just equate them. But then I realized as I did it, it's easier just to solve the B. But either way. Questions on that? Okay, let's go on to the equations. This is very much like kind of quiz type problems you might have in like a newspaper or something. And like solving sort of things. Alright. Let's do page 353. Let's just do a basic equation to get us started. So say we have, let's just start with number 4, right? X over 4
equals minus 6.
minus 16, right?
Yes.
Very simple equation. Because remember what you do?
Yeah.
You need to isolate the variable. Right, so how do we do that thing? Multiply both sides by 4, that's right. So multiply by 4, multiply by 4. So these 4 cancel, and x equals minus 16 times 4, which is minus 64, exactly. Yeah, so that's your basic equation. Let me do another one of that type. We'll do number 6. Of that type is y minus 17 equals
minus 30.
minus 30. Okay. And again, we want to get the variable by itself.
Yes.
Right? So in this case, to get rid of the number, we have to add 17.
Yes.
Right? So we add 17 both sides. Right? So then y is by itself, and minus 30 plus 17 minus 13. So it's a negative and a positive, so we find the difference.
Yeah.
Negative is bigger, so it's minus 13. There. So you guys got that. Those are the more simple ones. Alright. Hi, you're welcome. Thank you. So now let's say we do number, let's do number 9. That one's slightly different. It has 12 over x equals negative 3, right?
Yes.
Okay. So now we have a problem because the variable's on the bottom, on the denominator, right? So it's not so easy to just multiply and subtract. We need to do something with that variable. Pardon?
No.
You can, yes.
We multiply by x actually.
So we can multiply both sides by x.
Yes.
Alright? What you can also do, so we'll do this way first. You just multiply both sides by x. So 12 over x times x equals negative 3 times x.
Yes.
Alright? And here we get rid of the x on the bottom, and now we have the x in a more manageable place.
Minus 3x.
Alright, so we have 12 equals minus 3x. And now we can isolate x by itself.
Yeah.
Alright? So now we have to get rid of this minus 3. What do we do? We divide, right? So divide by minus 3, divide by minus 3. They will cancel. And 12 divided by minus 3?
Minus 4.
Minus 4, because there's one negative, so it becomes a minus. That means minus 4 equals x, or x equals minus 4. Another way you could do this is when you have something like a fraction on each side and no pluses or minus, you can do a cross multiply. I think that's what you were trying to say, right? So you can see through 12 over x, I'll just do it like this, equals minus 3, and we can see it's over 1. Right? Any number can be over 1. So we can cross multiply, which means we can go like this. Right? We can switch these two. So that means that we go straight to 12 over minus 3 equals x. Times x over 1, which is just x. And then we can solve again. Now we're here already. So then minus 4 equals x. It's a bit of a quicker way. So if you want to try it, you can do that. You could also say you're cross multiplying this way. 12 times 1 is 1. Right? Okay, so that's something to keep in mind if you remember from back when we did fractions. If you have that equals, you can cross multiply. Switch these two around. This is basically just saying the same thing we did here. Right? Multiply both sides by x, divide both sides by minus 3. It's the same as switching these two across the equal sign. Alright. Then, are there any questions on that? Picture of it? There we go. There was one more I wanted to make sure we covered. And let's see. I think. No, let me just do another 27. If there's no others before we get to the word columns. The rest of them you guys okay with? Alright, so we'll do 27. 27 has 14 minus W equals what? 42? Okay. So in this one, the challenge is that you have a minus of your variable, right? So it means we are going to have to do it in 2 steps. So the first step, we want to get rid of the 14. Okay? Because again, there's 2 ways you could do this. First, we could just subtract the 14, right?
Minus 14.
Subtract 14 from both sides. So this is nothing, but we have a minus still.
Yes.
So you need to keep it minus, right? Minus W equals 42 minus 14. What is that? 28, that's right. So minus W equals 28. So then to get rid of the minus, right, we multiply it by negative 1.
We divide it by...
Or divide by negative 1. Either way, because all you need is to get the negative. Okay? So if you multiply this by negative 1, we can do the same to the other side, right? So minus times minus becomes positive. So we get a positive W, and 28 times minus 1 is minus 28. Okay?
Yeah, that's not a problem.
So that's no problem? Yes. Doing this here. So we ended up with a negative W, right? And we want to have a plain W. We don't want it negative. Right? So imagine what we're doing is it's negative something equals 28. Right? The x is just a sum. The W is just a something. The variable is a something. So negative what is 28? Okay? So to get to a positive number from a negative, we say it's going to be a negative inside, so we can do negative, negative. So that's why, if you think about it, our answer is negative 28. So minus 28, right? This equals 28. Minus, right? So that means our W has to be negative 28 over here. So negative something equals negative 28 is the same as saying something equals negative 28. Because the signs are flipping. Right? So we multiply it through by minus 1, everything flips. It's basically whatever is on, we turn off, whatever is off, we turn on. Right? So we go through this whole equation over here. And if it's a minus, we make it a positive. If it's a positive, we make it a minus, a negative. Because that's what's happening here. We do negative this. Negative, negative equals 28. And you could, if you want, you could put it back in. Right? 14 minus negative 28. And that's this thing here. That equals 14 plus 28, which equals 42. Original.
Backward.
Pardon?
Backward.
Backwards, yeah. So it's kind of checking your work. You put it back in, what you found. So the key thing here is to understand the negative numbers, right? Basically, if you have a negative variable and you want it to be positive, just multiply it by a negative 1. Right? Negative 1 will change everything. But it's an equation. So whatever you do to one side, you have to do to the other side. So I multiply this by negative 1 to get it positive. That means I have to do the other side also by negative 1, which turns out negative. Okay? Now there's one other way you could do this. And that is, say you have your negative here. So we have what? 14 minus W equals 42. Say we have this negative here. The same way that we multiply both sides by x to get out of the denominator, we could actually add W to both sides. Alright? So if we add W, it becomes 14 equals 42 plus W. You see that? I added W here, cancel this one, and come on this side. In fact, I almost imagine that what I'm doing is I'm adding W. But imagine that I'm moving it to this side. Right? But when I move it to this side, it becomes positive. Right? I'm adding it. So I'm kind of taking this W and boop, now it's here. Right? But here was minus, here's plus, because I had to move it over. Okay? And then we solve for this. So W and plus 42, we want to get rid of the 42, right?
Yeah.
So we subtract 42 from both sides. I'm just going to say we have plus W plus W, right? So here we're going to subtract 42. Here we'll subtract 42. Alright? So this one cancels. We get W on this side. Well, what is 14 plus 42? Minus 42. Minus 28. Same answer. So there's two ways if you have a negative variable, there's two ways you can do it. The one is you just solve out until you have negative and then you multiply through by minus 1. The other is you subtract by that negative variable. You add, sorry, that negative variable to both sides. And it just moves over. Okay? Alright, 27. Let's do some word problems then. This will be good practice. Let's see. The first one is number 29. Oh, we have a table. Alright?
Yeah.
Table is kind of like this. One, two, 4, and it's got 36, 40, 40, and here's 28, 4, and 38. This one is Kyla, and this one is Aaron, right?
Yeah.
And this is hours per week. Just abbreviating. Okay, hours per week. Okay, and this is week 1, 2, 3, and 4. So it says Kyla and Aaron worked a total of 77 hours during week 1. So week 1 here, right? This is week 1. Says the total was 77 hours. So week 1 total 77 hours. All right. And what it says is let X equal Aaron's hours for week 1 because we have nothing here, right? We don't know what it is.
Yeah.
So it's an unknown. So X. X is Aaron. So which of the following equations can be used to solve for Aaron's hours during week 1? So the total is 77, right? So it's going to be 36 plus X.
Yes, 36.
Yeah, so 36 plus whatever her hours are
Yeah.
equals 77.
Yes.
So that's our equation. They're kind of showing you how you build in a word problem. Right? Normally what they might say is, they would just say the total, in week 1 is total of 77 hours. How many hours did Aaron work? Right? And then you would say, okay, 36 plus X equals 77. Solve for X or subtract 36 from each side. And Aaron is like 41 or something.
31. What?
41, yeah.
Oh, okay.
So, but this one we have it already. It says X plus 36. C. Any questions on that? All right, let's do number 30. Number 30 says, Aaron worked twice as many hours as Kyla did during week 4. So let Y equal Kyla's hours for week 4. So here's Y, week 4, right? And what we know is that Aaron worked twice as many. So which of the following equations could be used to solve for Kyla's hours during week 4? Well, let's look at it. So now, Aaron worked 2 times Tyler did, right? Aaron worked twice as many. Okay. So that means Aaron, which is 38, that equals, Aaron is 38, that equals 2 times whatever y is, right?
Yeah.
Because y is the unknown, and we know that 2 times this is this one, right? So here we have it. Basically, you just kind of think through it. This is 2 times what this is, and this one is 38, and this one is y. So it's 2y. Okay? It's kind of fitting it through. And if we were to solve for y, then it would be
19.
yeah, 19. But they just want us to know which of the following can be used to solve. And that one is C. Yes. C. 2y equals C. Any questions on that? Now, if you're taking the test, you have to run out of time, and you put C. You're going to both of these right. Alright? But hopefully you won't come to that. Alright. Any questions on these two? Now let's do the next ones. Okay, number 31. Oh, it's one of these. Right, the quotient.
Of a number divided by
Quotient of a number divided by 4
is 32.
32
Yes.
is 32. Okay. So what is the number? Alright. So the quotient of a number divided by 4 is 32. So the number is going to be x. Okay? And the quotient is the result of something divided, right?
Yeah.
So the quotient of a number divided by 4 equals 32. So this is a number divided by 4,
Equals 32.
and the quotient is 32.
Yes.
Okay? So it's kind of using these things we have here. Catherine, by the way, did you get Louis' text?
No, yeah,
Oh, yeah. You put it in? Yeah, in her drawer. I put them in her drawer. Okay, so do you see, bye-bye. You see how I got here? So this is a number, and a number divided by 4. This is the quotient of that is 32. So the quotient is the result of the division. So this divided by 4 is, equals is going to be, is 32. Okay? This is the difficult stage, going from the text to the math, right?
yeah.
Once you're here, you can solve for it. Does everyone know see how I got from here to here? Right? And then the quotient equals divide, the result of dividing, right? And it's a number divided by 4. So the quotient of the number divided by 4. So the number is x, divided by 4, and then is going to be our equals.
Yes.
Okay, is this. Because you can have the sum, because the sum of the number and 4, sum of the number plus 4, is 3, would be x plus 4 equals 3. Alright? That sort of thing.
And
So now we solve for this. We multiply both sides by 4. Right?
sorry. 72.
X equals
128.
128.
Yes.
Yep. See? Again. Well, don't worry, sometimes it can be all A's, but you know. number 32. Right, the solution x minus 5 makes which of the following equations true? Okay. So x equals minus 5, and we have these different equations, right? Which one is A? 14 minus x equals 9. B is x over 5 equals 1. What's C?
X plus 3 equal 8.
X plus 3 equals 8.
D.
D.
12x equals
12x equals what?
60.
60.
Negative.
Negative 60.
Yeah, negative 6.
Okay.
This one is.
I was wondering because I didn't see any that were working. Okay. So what we basically have to do is just plug it in, right? It's substitution. Okay? So this one is going to be 14 minus negative 5, right? That's going to be 14 plus 5, which is 19. Not A. This one is going to be negative 5 divided by 5. That's going to be 1. Oh, negative 1.
Negative 1.
Right? So that's not changed. This is 1. This one is going to be negative 5 plus 3. Is it times?
Negative 2.
Plus 3. Plus 3. So minus 5 plus 3 is minus 2. So it's not 8.
Negative 2.
So it has to be D. But we can do it. 12 times minus 5. Yes, that equals negative 60. So it's this one.
That we have to divide by 12. X equals minus 5.
Yes. You could. The other way you could do it is you could solve each of these for x and see which one gives you x equals minus 5. Right? I think it's easier to substitute them in. I think it's quicker that way. But if you want, like I would basically, this one I put x on this side and 9 on this side, so it becomes 14 minus 9 equals x. That would be 5. So x is 5 in this one. This one multiplied by 5, x equals 5. This one subtract 3 on both sides, x equals 5. This one divided by 12, x equals minus 5. So you can do either way to solve it. Any questions on that? Good practice. We'll do number 33. That's got a whole bunch of money. So we have here number 33. Because Mike had 572.18 his checking account. After writing a check, he had the smaller number. Which of the following equations can be used to find the amount of the check?
I didn't say.
No, it's probably not A. Let's have a look at it. So C equals the amount of the check, right?
Yeah.
The unknown. And we start with 572.18, right? And we end with 434.68. Right, this is what was in the account before. This is what was in the account afterwards. Okay? So what happens, you write the check and the money comes out of the account. Right? So we need to take the total and we subtract
Yes.
the amount.
Yes, subtract.
Subtract. So then it's going to become 572.18 minus C gives us 434.68. Right? Because by subtracting C, we got to this amount. And you can see it, because it started bigger, it became smaller.
Yeah.
So we subtracted something. Alright? And which one is that? B. Okay? Any questions on that? Alright, let's go on to the next page. And these are what they call multi-step equations. Page 355. We just start on some of these. So a lot of them require you to do whatever you do to one side of the equation, you do to the other side of the equation. And your goal is to always get the variable by itself with no coefficient. So whatever you have to do to get there. So I'll do just an example, we'll do 5, and then we can start doing some of the ones you guys said would help. So number 5, 5y
Plus 2 times 5.
times 3
Times 5 plus 2.
times y plus 2 equals
54.
54. Okay. So the first one's going to be like simplifying the polynomial, right? We have this here, we just need to simplify it using our order of operations. Okay, so first we do brackets, okay? There's nothing inside the brackets we can solve because this is a variable. So we have to put the distributive property, put this coefficient inside each one. Right? So it becomes 5y plus 3 times y plus 6 equals 54. Okay, now we have two like terms, right? So we can add them together. That's right. 8y plus 6 plus 54. Okay. Now first we want to get rid of the... So in these equations, the first thing you want to do when you have a variable with a coefficient and it's a plus or a minus, first you want to do the adding and subtracting so you have just the variable. Right? You want to get rid of the constant. So first do the adding and subtracting, get rid of the variable, and then you can do the multiplying and dividing. Unless you can see like it's an 8 and an 8, then maybe I'll divide through by 8. But it's not, usually it's easier to just do this, so we subtract 6 from each side, right? So now we get 8y 48, that's right. And now we have just the variable, so we can divide by 8 on both sides. So y equals 6. Good job. Yeah. And if you put it back in, you would see y, 6 plus 2 is 8, right? 8 times 3 is 24. And 5 times 6 is 30. 24 plus 30 is 54. Alright, so let's do number 11. And can we, do you have any questions you want to go over specifically? Yeah? Okay. No, also? You have a specific going to look at? Or around? Yeah? 10. Number 10? And 14? Yeah, we're going to do 14. Hold on, any, you want to look at? That's good? Okay, so let's do number 10. Yeah, thank you. 50
Equals 3 times s plus
3s plus
16.
brackets? Oh, s in brackets, okay. Plus 16, yeah?
Minus 2.
Bracket, yeah?
S minus 2.
S minus 2. Okay, so we're going to have to do the same thing. Pretty much the same kind of problem, okay? We simplify it and then we solve it. So we keep, and if you see, I always write the same, right? I try to keep the equals in the same place. So this here is going to become what? 3s plus 3 times 16? 48. That's right. Plus 48. Well, how about here?
Minus 2s
Minus 2s.
plus 4.
Because minus 2 times minus 2 is plus 4. Okay, so we have 2 s's and 2 constants. So we need to 50. So what's 3s minus 2s? S. What's 48 plus 4?
52.
So that's plus 52, and this is an S. Looks like a 5.
That's the 5 minus 2.
Okay. So now, we actually don't have a coefficient here, so it's going to be even easier. We just have to get rid of this. So we subtract each side by 52.
Yeah.
Right? Or subtract 52 from each side. Minus 52. So these cancel, and what's 50 minus 52?
Minus 2.
Minus 2. That's right. So minus 2 equals S, or S equals minus 2. Okay? Any questions? Move on. Yeah. You start from 15? 52. Oh, and you subtract 50? But then you have S on this side. So then you, if you did minus 50, yeah, so if you had, you're saying like you go here, 50 equals S plus 52, right? And you want to subtract 50. Because now we have 0 equals S plus 2.
2.
Right? Because we subtracted 50 from each side. Now that's fine,
That's fine.
because now you just subtract 2 from each side.
Yes.
Right? To get it over here. So I would subtract 2. And again, I get minus 2 equals S. You see? I get the same way. But if I just added an extra step.
No, I mean like
No, it won't. Because your equation, you're starting here, right?
yeah.
50 equals S plus 52.
Yeah.
Okay? So if I subtract 50, I have to basically, what I'm doing is, what I do to one side, I do to the other side.
Yeah.
So you're subtracting 50 here, and you get 0 on this side.
Yeah.
You subtract 50 here, and you get S plus 2.
Yeah.
So you get 0 equals S plus 2. But that doesn't tell me what S equals. It tells me S plus 2 equals 0. So that means for something plus 2 to equal 0, it has to be minus 2. Because minus 2 plus 2 equals 0. Right? So you get to here. You could just see it straight if you wanted to. You could say, oh, obviously it's minus 2 to equals 0. Or you subtract 2 from both sides, and you get S equals minus 2.
So I don't know, but here
No,
also,
how about here it's 8y plus 6, then we subtract the 6.
Yeah, subtract the 6. Because what I'm trying to do is I'm trying to isolate the variable. I want to isolate the variable.
One side.
So I want this, I see the S. I want the S by itself. Alright? I want the variable term to be on one side of the equals, and everything else on the other side of the equals. Okay? So here, the first thing I do is I'll keep the constant, I'll keep the coefficient, and I'll keep the number that's with the variable, and I subtract by 6, so now the variable's on its own, and I have just a number here. And then I can divide by the coefficient. So I'm always looking for how can I get my variable by itself on one side of the equation. So it's the same here. This is why over here, I decided I had a variable here. So I want to get rid of whatever else is with the variable.
yeah.
All right? So here, doing the 50 is not going to help me because I won't get rid of this.
Yeah. So now in reality,
Yeah.
because the sign of equal is after the
Yeah, it's true. Oh, you're wanting to put it on the other side. It doesn't matter. Because equals is equals.
So it's like 15
Mhm.
plus S, and then
So I see what you're saying. I could easily write this
equal 52.
S plus 52 equals 50. It's the exact same.
Yeah.
Okay? Because an equals is an equals. 4 equals 4. 4 equals 4. If it equals is equals, doesn't matter which side of the equals you put it on.
Yeah.
right? That's the thing with the equals. So is that you kind of wanted to have the s on the left side. I can see that. It's nice and consistent. What I do is I try to solve it whatever side the variable ends up on. And then in the end, like here minus 2 equals s, then I can switch it to say s equals minus 2. Okay? Think of it like in Arabic and Hebrew we go right to left, right?
Yeah.
Here we do left to right. This is equals, so it kind of doesn't matter.
Yeah, because sometimes it works from right to left and sometimes from left to right. That's why you find sometimes.
Yeah, and it kind of just depends on how they set up the equation in the beginning. Because you see on this one they had the variables on this side. And this one they had the variables on this side. But it doesn't matter. In fact, you could even write this one the other way around. This is important. This is the beautiful thing with the equal sign, right? Is that equal sign is basically telling you whatever is here is the exact same as what's on the other side. We just have some unknown number. We don't know all the pieces. But because there's an equation, because it's equal, you can always know whatever's on this side equals whatever's on that side. So then I can do anything to this side. If I'm going to do the exact same to the other side, it will still remain equal. That's the whole theory behind the equation, right? So I have 4 on this side and 4 on this side. So I add 20 to each side, right? This one becomes 24. This one becomes 24. They're still equal. The most important thing is that relationship of equals. But because it's algebra, we don't know one of the pieces. But it doesn't matter because even if we don't know one of the pieces, we still know that each side equals each other. So we can do whatever we want to each side until we've solved, we have just the one piece that's unknown all by itself. Okay, any questions? Any other questions? This is a good question. I'm glad I want you guys, when you have these sort of things, to ask me, because that's the whole point. I can just give you exercises, but if you're not quite understanding it, I want you to understand it so that you can feel more confident in your solving. Yeah. Alright, then let's move on. Let's do number 11. And then we'll take a break, I think. Number 11. Alright. 5 bracket 2x minus 10
over 2
over 2
plus 14
plus 14 equals 19.
19.
Equals 19. Alright. So this is a bit complicated. Alright? So when I see something like this, I see there's 2 things I need to be doing. The first is I want to get rid of this thing, right, the plus. And second, I really don't like this denominator, right? I want to get rid of the fraction. Okay? So we can do that. Before we even solve for x, let's get rid of those parts. And because it's an equation, we can do that, alright? So let's get rid of the 14 first. And to do that, I subtract 14 from each side, right? So subtract 14, subtract 14. So now that equals, that becomes 5 2x minus 10 over 2 equals 19 minus 14?
5.
5. Alright, already it looks a lot simpler, right?
Yeah.
Okay, and now, so it's kind of like basically, it's as if I took this whole thing and made that like a y, right? It's as if I said that y equals 5 times 2x minus 10, right? And then I have y over 2 plus 14 equals 19. And then I solve for y. And then I put this back in, right? It's kind of just I'm using the same techniques. Right? So now we want to get rid of the 2. So we multiply both sides by 2. Right?
Yeah.
That gets rid of this 2. We cancel. And we get 5 times 2x minus 10 equals
10.
10. All right. Now it's a little easier. Now I want to get rid of this 5. Right? So I'm trying to isolate the x. There's 2 ways I can do it.
Yeah.
One, I can just multiply it in and solve for x. Right? The other, I can divide both of these by 5.
Yes.
So I just get this equation here. Now that's what I'm kind of tempted to do. So I'll do it that way. I'll do both ways. One way we do like this, and I just divide each of them by 5. So it becomes 5, 2x minus 10 over 5 equals 10 over 5. Okay. I will solve this one out. So this becomes 2x minus 10 equals 2. Right?
Yeah.
Should I add 10 to both sides?
2x, 12.
And I get 2x equals 12. And now it's divide by 2 on each side. And x equals 6. Sorry, it's a bit hard to see. Pardon? No? Okay. Then we can try this way. Okay, another way you can do it is you multiply this through. So what's 5 times 2x?
10x
10x.
minus
5 times minus 10?
minus 50
Minus 50 equals 10.
10.
Right? So there's 2 different ways to do it.
Yes.
Right? So here, we want to get rid of this 50, right?
Yeah.
So how are we going to do that?
We add 50.
Add 50, right?
Yes.
Add 50 to both sides.
Yes.
So now we get 10x
Equals 6.
equals 60. Okay?
Yeah.
Divide both by 10,
Yes.
and we get x
Equals
equals 6. Same.
I
We hope
did this.
do it this way.
Yeah.
Either way is good. Either way looks easier to use. It's fine. That's the point. The thing with the equation is as long as you do something to one side, you do something to the other side, and you're always trying to get the x by itself. Right? That's your goal. You start to think out, how can I get x by itself? What am I doing? I need to get rid of the extra stuff. Alright. Any other questions on this? How to do it? So what I did, I said, it's just piece at a time. This looks complicated. I don't have to worry about it yet. I just take each piece. So I take first, get rid of the 14. Now I have this one. Second, get rid of the 2s. Now I'm here. Now I have a choice. I can divide by 5, or I can multiply through and then solve it. If I multiply through, I just multiply, then get rid of the 50, and I have 10, and get rid of the 10, and I have my answer. This one I divide by 5 each side, and I get a more simple equation. But I have to do the same thing. So get rid of the 10s, and then divide to solve it. Questions? No? Okay, let's have a 5-minute break. Alright, so I realized, looking at this one, there's actually another way we could solve it. And that was, if we go from here, we could actually do something here. So this could become 5, and we see there's a 2x and a minus 10.
Yes.
Both have a 2 in them. So it could become 5
X
times
minus 5.
2 times x minus 5
Yes.
over 2 plus 14 equals 19. See that?
Yes.
I used the distributive property to pull out a common 2. So there's 2 here and a 2 here. And 2 times x will become 2x, and 2 times minus 5 becomes minus 10.
Yes.
So I'll pull the 2 out, and then I can easily cancel them.
Yes.
Right? Here. So then I get 5 x minus 5 plus 14 equals 19. Then I can simplify this one. It will become 5x
Minus 25
minus 25
plus
plus 14 equals 19. Then we get 5x plus minus 25 plus 14 minus 11
minus 11, sorry.
equals 19. And now this is much simpler, right?
Yes.
Right? So then we do, this is to add 11 to both sides. So 5x equals 19 plus
30.
11,
30.
30. Divide by 5,
6.
x equals 6. Same. Just so you see, there's actually a third way to solve it, using the distributive property. Very good. This was the hard part, and then after that it's easy.
So what I do multiply 28 divided by 5.
28 divided by 5.
That's why it gave me 5.6.
One side.
Where did you get 28 from?
No, where did you get
Did you
the
multiply everything by 5, by 2? Did you multiply everything by 2 to get 28? I don't know where you got 28.
No,
Because
no,
it's
by 2.
5.
Pardon?
By 2.
Here?
Yeah,
Did you multiply by 2?
yes.
So that's how you got 28 here. So you should get 38 here. You could do that.
Okay.
Then you have to subtract 28 from 38. You get 10. And then you would solve it. You could do that. That would work. Did you get 6?
No,
No?
get 5 on.
Okay. Well, fine. No, you know what? This is good practice. Let's try it. Try it. And then you can find out where you went wrong. Yeah, so what Malachi was saying is that he doesn't like the 2. He's going to multiply everything by 2. Multiply one side by 2, multiply the other side by 2. So this becomes times 2. So it becomes basically 2 times this whole thing. Right? Okay, so we multiply this side by 2 and this side by 2. If you do this, you have to multiply the whole thing. Alright? So this one is going to cancel. So that'll become 5 times 2x minus 10. And here 2 times 14 is 28.
Yes.
So 19 times 2 is 38.
38.
Did you get here, Malco?
Yeah, no,
No?
I get the stuff from 28.
You just solved from 28?
Just one side.
One side.
Oh, you only did the one side?
Yeah.
Oh, you didn't do times 2 on the other side. So that's the important thing. The equations, if you do it to one side, you have to do it to the other side.
Yeah.
And if you do it to the one side, you do it to the whole, everything on this side. So this is multiplying by 2. We do the whole thing by 2. But you could come here and then say, let's solve this out. So that would become 10x minus 50,
50.
right? Plus 28 equals 38. 10x plus minus 50 plus 28.
No, minus 32.
22. Minus 22
Minus
equals 38. And we add 22 to both sides. So we get
Yes.
10x equals
60.
60. And again,
Yes.
x equals
Equals
6.
6.
It's fine, it works. This is the thing. There are many different ways
Yes.
you can solve these problems.
I didn't do 19 times 2.
So that was your problem. Yeah, okay. But this all these, we just solved this problem 4 different ways. Right?
Yeah.
But we all came to the same problem. And that's the point. So there's not necessarily like one right way to do it. So you might be sort of saying, oh no, should I do it this way? Should I do it that way? Just pick one and roll with it. But remember, you're always trying to isolate the variable. So you're always trying to get the variable by itself on one side. So whatever else you can. Simplify and isolate the variable. Even here, I could have subtracted 38 from both sides and then solved. Right? It doesn't matter, just as long as you keep it equal. Whatever you do to one side, you have to do to the other side. Okay. Let's go on with the next one, number 14. Take a picture of this second round. In some ways, this is part of what I like about equations, is that there's many different ways to the same answer. It's kind of sort of intellectually interesting, enjoyable to see how you can solve it. So number 14 is 38 equals 5 bracket b minus 3
Plus 13
plus 3b
plus 1.
plus 1
think, yeah.
That's the whole thing?
14.
Yeah. 14. Okay. 5b minus 2b minus 3.
Yes. 2
2b minus 3.
Yeah.
Yeah, okay. So the first thing I'm going to do is just simplify this side. Right? So, and by the way, Abdullah, I'm pretty sure my variable is going to end up on the right side this time. Just because I see the variables here, it's probably going to end up being like that. So it'll be like that one we did before. So 38. So what is 5 times 2b?
10b.
10b. What is 5 times minus 3?
15.
Minus 15. Good.
Plus
Plus
3b.
3b plus 1. Alright, so we have b and b. So constant and constant. So what's 10b plus 3b?
13, sorry.
13b. What is minus 15 plus 1?
Minus 14.
Minus 14. Okay. So now we have, so at this stage, if it bothers you, Abdullah, you could rewrite it as 13b minus 14 equals 38.
Actually, I guess before we start, I guess speaking here, like, you know, we have to start from right to left, like, at like plus 14 and 38.
Plus 14.
Yeah, and then we divide by 13.
Yeah, that's how we do it.
That's what I was thinking that we are going to say.
Yeah, good.
Because
Yeah. So you don't need to worry about this.
Yeah.
I'm just showing you if it really bothers you that the variable's on the right side instead of the left side. You could rewrite it this way. But we'll solve it like as you said, exactly. So we're going to add 14 to both sides, right? So add 14, add 14. So this time we'll get 13b by itself here. And what is 38 plus 14?
52.
52. Alright. And then, as you said, divide both sides by 13. What is 52 divided by 13?
4.
Very convenient. Somebody has thought ahead of time. Right? So it's not a fraction or something. 4 equals b.
B.
Or b equals 4. Any questions on that? No? Good. Alright, let's see. Number 21. Let's try some of the word problems. I think you guys are getting this. So let's try some word problems here. So 21. Number 21. What does it say? 3 times, oh, one of these. 3 times a number increased by 9 is 15 less than 6 times the number. Okay, let x equal the unknown number. Which of the following equations could be used to find the value of x? So we have 3 times, right, 3 times x, we'll just say 3 times x, increased by 9, so plus 9, is going to be equals 15 less than 6 times the number. So 6 times x minus 15, right? 15 less than.
Yeah.
So then we have 3x plus 9 equals 6x minus 15. Yeah, D.
Equals.
D, I think. Yeah, D. You kind of have to read it out, right? So 3 times a number, so 3x, increased by 9 means plus 9.
Plus 9.
Is your equals. Always is your equals.
Yeah.
Is. And then it's a bit weird because it's 15 less than 6 times the number. So we could do like minus 15 plus 6 times the number, but it's easier to say like, so it is 6 times the number minus 15. So it's 15 less than 6 times the number. I think these are difficult if your first language is not English. You have to track exactly where in the sentence this is going. You guys should just, you try this in practice. But I find that sometimes it's a little bad to like think about it. Okay, what do they mean 15 less than?
Yeah, it's really confusing.
Yeah.
The word probably.
Yeah, especially this kind of word problem, I think is the harder one. because it's got these weird, like, to follow, like, what exactly is the number in here. But here, so the first we did is 5. 3 times the number increased by 9 is, that's equals. And then, so that way actually immediately knows between C and D, right? So the first half. And then the next one it says 15 less than. So if it was 15 less, 6 times the number would be 15 minus 6x. But 15 less than
Yes.
6 times the number is 15 less than the next thing. So it's 6x minus 15. Yeah.
Sure.
Yes.
I want to ask some, go to 14 again.
Yep.
So I want to know, where is that come from?
13.
Yes.
So we have simplifying this, right? So 5 times 2b becomes 10b.
Yes.
And we have a 3b here. So we add 10b plus 3b equals 13b.
But it's minus.
This minus 15. This plus 3b. The minus is coming here. 5 times minus 3. But this whole thing is then plus 3b. So the b here is plus and the b here is plus. So these ones add. And this one subtract. Remember, this is b, and this is a constant, so you can't add these. You can only add if it has the exact same variables.
Okay.
So 10b plus 3b is 13b. Yeah. Alright, let's try number 22. It's good that we spend, I'm wanting to spend a lot of time on these word problems because your lesson today is also word problems. Okay, so let's see. Says, let me erase this. Number 22. It says, Dave has 500 baseball cards, right?
Yeah.
Which is as many as Eric and Travis have combined. Eric has 3 times as many cards as Travis has. And then they give you a little chart. That's nice.
Yeah.
That's a good, like, first step, right? So it says Dave has 500. That equals Eric and Travis, right? And we also know that Eric has 3 times as many cards as Travis has. So Eric equals 3 times Travis, right? Okay. So here they say, and then they give you this little chart. From the information, you can write the equation 3x plus x equals 500. So how many cards does Eric have? So they're actually giving it to you. Instead of t, they're saying x, right? So we have 500 equals 3x plus x, right? So if Travis is x, then Eric is 3x. And together they equal 500. They're showing you kind of how you build the equation from the word problem. So this is now our equation. And the question though, this is the tricky part. The question wants to know Eric. Not Travis,
Yeah.
Eric. Right? So first let's solve for Travis and then we can find Eric. So 500 equals
4x.
4x, right? So what does x equal?
125.
Sorry, divide both sides by 4. And x equals 125. Correct. And now, Eric is 3x, right?
Yeah.
Equals 3 times 125. Which equals, what was that?
375.
375. Right. So they're helping you here. They're giving you that chart.
Yeah.
And you see how I do it? I said this one is E times T and E equals 3T. So I would have just gotten basically put in place of E, I would have put 3T here, and that's how you get 3x.
And instead of X, we can work with T as well.
Yeah, you could use T. T works as a variable. Alright. And let's take a picture of that. Another one of these quotient number questions. The difference of 4 times a number and 7 is 15 plus the quotient of the number and 3. Which of the following equations we use to find the value of x? So the number is going to be x. So we have the difference. Let me write this out. Difference of
7 x minus 7.
4
X over 4. No.
Let me just write it out and then we'll solve it. 4 times, I'll do x, and 7
Minus 7.
is 15
plus
plus quotient, I'm just going to abbreviate that,
Quotient of
number
of 3.
and 3. Okay.
X over 3.
So 4 times x is just going to be 4x,
4x.
right?
Yeah.
We have an equals is right? Is 15 plus quotient is x
X over 3.
over 3, right? And this one is the difference
Minus
of 4 and 7, so it's going to be 4 minus
7.
7. The difference is a minus, right? See how I got that?
Yeah.
I wrote it out. I put the equals under is. 4 times x I can do together. Quotient of x and 3 I can do together. And then I look at what are my pluses and my minuses. 15 plus this. And difference of this and this is going to be this minus this. Okay? So that's then, I'll write that more closely. 4x minus 7 equals 15 plus x over 3. Where is that?
A.
It's A, right?
Yeah.
Yeah. Because A has x over 3 plus 15. It's the same thing. Yeah. Now what's difficult is it's 4x minus 7, not 7 minus 4x. Right? That's why it was difference of 4 times x and 7 rather than 7 and 4 times x. Alright. Questions on this one? How would I go about solving it? What would I do first?
Here,
Mm-hmm.
multiply by 3. The
Four.
first step,
Yeah.
Divided by 4.
multiply by 3 to get rid of or to get rid of this 3.
It's not broken.
We need to multiply
And
by
then-
30 both sides.
Yes.
Multiply.
Yeah, so there's different ways we can do it. So you guys are saying let's get rid of this first. We could do that. I think what I want to do is get all the x's on one side and all the numbers on the other side first, and then we'll multiply by 3.
Yes.
Okay? So what I'm going to do is first I add 7 each side. Okay, so I have 4x equals 22 plus x over 3.
3, yes.
Now I want this one on this side.
Yeah.
Okay, so subtract x over 3. And now I get 4x minus x over 3 equals 22.
22.
And now I'll do what you guys are saying. Let's multiply, I want to get rid of the 3. So I multiply the whole thing by 3, multiply this by 3. So 3 times 4 is 12.
Yes.
3 times this is cancelled, so it becomes minus x
Yes.
equals 22 times 3 is 66.
66.
Alright? Now 12x minus x is what?
Yes, 11x.
11x, because it's like a coefficient of 1 here. So 11x equals 66. Divide both sides by 11. X equals 6. X equals 6 a lot, doesn't it?
Yeah.
Alright, I just think it's good practice how we do it. Now, as you guys said, you could multiply the whole thing by 3 from the beginning. And that's fine too. There's many ways to do it as long as you always do whatever you do to one side, you do to the other side. And you're always moving towards simplification.
More simple than multiplying by 3 from the
beginning. That's why I thought I'd do it. Because I want to have, basically before I multiply by 3, I want to have less numbers. That means I have to do less multiplications. That's anyone's bag, is it? It's just sitting here? That's alright. Okay, so I'll take a picture of that. We'll do one more. Okay, number 24. Says Kim earned X dollars at his part-time job on Friday. His wife earned 12 more than twice Kim's pay. And then they put that in brackets for you, so it's nice. They actually give you the math of it. Together they earned 174. How much did Kim earn on Friday? And then they even give you the equation. Right? Very nice. So they're showing you how to build the equation. These problems are actually showing you how to do word problems. So this thing is his wife.
already solved.
Yeah, they already give you the equation, you just have to solve it. So his wife, so he earns X. X. Wife is 12 more.
2x plus 12.
12 more than 2 times X. Alright? Which is 2x plus 12. Okay. And then the total is 174, right?
Yes, 7.
So then we do Kim plus wife equals 174, which is x plus 2x plus 12 equals 174. So that's how they get to that equation, and then they give it to you nicely here. So now we have to solve this for x, right?
Yes.
And we have to be careful, it's Kim we're looking for, so we want x. If it was Kim's wife, we have to solve for x, and then put x in here. Right? But we're looking for Kim, so it's just x. So first we need to simplify this equation. Okay? What's x plus 2x? Alright, so that's 3x plus 12 equals 174. Alright, now we need to get rid of the 12, right? Subtract 12 from both sides. We get 3x equals, what's 174 minus 12?
162.
162. Alright. Divide both by 3. X equals what?
Oh, 54.
3 goes into 16, 5 times remainder 1, which is 12, which is 4. 54, yeah.
$54.
Dollars? Does it say dollars? Yes.
Not sure.
There, dollars. Happy? In science, it's very important to put the units.
Yeah.
So it's good practice. Alright, $54. Any questions on that? Let's keep on doing word problems. That's part of the lesson for today. So basically, word problems just require a lot of practice. Just figuring out how to do these, how to move through them. How to figure them out. So I'm just going to go through, they give you some examples here, so I'm going to go through these examples with you. And we can talk about it. Now say is this word. Consecutive. We'll start at consecutive numbers. Okay, consecutive numbers. The fancy word is saying it comes one after the other. Okay? So consecutive numbers are like 6, 7, 8, 9. They all go one after the other. 6, 7, 8, 9. Or 2, 3, 4. It basically just means it's one after the other. It's a consecutive number. So if you have a word problem saying, let's see, three consecutive numbers, but the sum of 3 consecutive numbers is 96. Sum of 3 consecutive numbers is 96. What are those numbers? The sum of 3 consecutive numbers is 96. What are the numbers? Okay? It's 96. So sum means you add them, right? So there's 3 numbers. So what you do for this kind of a problem is you say x is the first number. Okay? Then, since it's consecutive, the second number is x plus 1. Right? So the first number is 2, the next one is 3, which is 2 plus 1. And then the third number is what? X plus 2. That's right. X plus 2. Those are our consecutive numbers. We don't know which ones they are. That's why it's algebra. It's unknown. We don't know what they are, but we know that they go in order. X plus 1, x plus 2. Right? And it says the sum, which means adding them, of all 3 is 96. That means x plus 1 plus x plus 2 equals 96. If you want, you can put brackets around these. So you can see it's 3 numbers. 1, 2, 3. Okay? So then this becomes, let's just do it again. X plus 1 plus x plus 2 equals 96. So that's right. 1, 2, 3 x's.
Yeah.
So 3x
Plus 3
plus 3 equals 96. There's our equation. Alright? So we can solve this, right?
Yeah.
So we subtract 3 from each side.
Yes.
3x equals
93.
93. Now we divide each side by 3.
Yes. 31.
Yep, that's right. So x equals 93, 3 and 1, so x equals 31. So our consecutive numbers are, therefore, 31, 32, and 33. And try, if you add them, 63
Yes.
plus 33 is 96. This is how we use algebra. Alright? That's how you solve a consecutive number problem. A similar problem would be something like sum of 3 consecutive odd numbers is 39, I think. Let's try that. how are we going to do consecutive odd numbers?
Like one. Odd numbers is number that can be divided by itself or the number one.
So that's a prime number.
A prime number.
Odd is like, I think it is.
Zogi.
Zugi.
Zogi?
Zug is even number.
Yeah.
Zogi is even number.
What's the odd one? Izugi?
Zug is a odd
So
number.
it's Izugi. Odd. 1, 2, 1, 3, 5, 7, 9,
11.
all these.
These
Okay.
are odd numbers. Yes?
So consecutive odd numbers would be like 7, 9, 11,
one.
right? Or 13, 15, 17,
9.
19, yeah. So the consecutive, how much is between each one? 2, right? So do the same thing, but this time it's going to be x plus 2, x plus 4. Right? Because they're odd, but they come right after each other. So it's the same concept, except now it's an odd, so you have to put 2 between them, right? So if this one is 3, this one is 5, and this one is 7. That's the consecutive odd numbers. So now we do x plus 2 plus x plus 4 equals 39. Alright? Same idea? So yeah, 3x plus 6, 39. Alright? 3x plus 6 equals 39. Subtract 6, so we get 3x equals 33. Divide by 3, x equals 11. Alright? So our three numbers are 11, 13, and 15. If you count them, 11 plus 13 is 24. 24 plus 15 is 39. Just kind of figuring it out.
But how come that is 2 and 4?
2 and the 4?
Yeah.
Because I said they're odd numbers. So the distance between each odd number is 2. So whatever one we start on, whatever, we don't know what it is, whatever it is, we know that the next consecutive odd number is 2 more. Right? So if we start with 3, the next odd number is 5. So to get from 3 to 5, we add 2. Right? If we start from 3, then 5, and the next one is 7. To get from 3 to 7, we add 4. Right? The next one is 9. So if I had 4, it would be x plus 6. To get from 3 to 6, from 3 to 9 would be adding 6. So even though they're odd numbers, we're adding 2. Right? Because you want to keep it odd. If you add anything other than 2, it wouldn't be odd. Or if you added an odd number to an odd number. Right? Odd plus odd always equals even. Right? An odd number plus an odd number is always an even number. Because odd plus even is odd.
Is 9 an odd number?
9?
9.
Yes. It's not a prime number, it's an odd number.
Yeah, but identify that odd number cannot be divided. It can be divided by itself or the number 1.
No, that's prime.
Here,
What you're saying is prime numbers.
prime number. So
Yes. Prime number is 2, 3, 5, 7, 11, 13.
Those are Zogi.
But those are not Zugi and
No.
Zugi. No.
this is not زوجي إنما الفردي.
So there's a difference between, yeah.
الفرق بين العدد الفردي والعدد الزوجي. Odd number, even number.
Yeah, so the thing is, with prime numbers, every prime number other than 2 is an odd number. Because otherwise it would be divisible by 2. Right? Every even number is divisible by 2. So you can't be a prime number if you're divisible by 2,
Yeah.
unless you are 2 yourself. That's why it can be a little confusing, because other than 2, every prime number is also odd.
Yeah.
But not every odd number is a prime number. Because you can have 3 times 3 or 3 times 7, right? There's no evens in it, but it still has numbers. Yeah. All right. The other word problems is basically just practice. Okay? So I'm going to do this example number 3 here. We can look at that. So it says ticket prices for play are $12 for adults. And $8 for children. $8 for children. Okay? And they sold 200 tickets. One night, the box office sold 200 tickets. The total box office receipts, the total money was 2,240, right? So they want to know how many adult tickets. All right, so we have 12 for adults, 8 for children. We sold 200. Total money was this. How much is the adult tickets? So what we can say here is, let's make X what we're trying to find, right? X is the unknown. X equals number of adult tickets. X is the number of adult tickets, right? Now we need to know if we have X adults, how many children, right? So what we can do is we know we have the total is 200. The total of 200 tickets. So if of those 200, X are the adults, how many are the children?
200 minus X.
200 minus X, right? So say we can just think about it. If X was like 100, right? Then there was 100 children. If X was 150, then there were 50 children tickets. That's what you're doing in your head. What you're doing is 200 minus how many adults you have. So children (200 minus X). So you kind of, this is, so many times when I do word problems, I do like this sort of step, and then I do a mental trick because like it doesn't make sense. Alright? So like I know X, so like I said, I think I've told you guys this before, but you kind of think about it. Alright, so X is unknown. If X were 100, how many children would I have? Also 100. So, and if X were 50, how many children would I have? 150. If X were 10, I'd have 190. And then you think, what am I doing? I'm doing 200 minus whatever X is, right? So that means the children is 200 minus X. So now if we have X and children, we know the totals, right? So 12X is how much money they make for the adult tickets, right? And then 8 times 200 minus X is how much money they make for the children tickets. And these two combined equals the total they got, right? So we can do 12X plus 8 times 200 minus X equals 2240. This is the key. Once we're here, we can solve for X. Right? You have to build it up. So this is money from adults. This is money from children. And then this is total. Is these two together. So kind of go a step at a time. And now we can solve for X. Alright, so let's solve this out. So 12X, what is 8 times 200?
1,600.
1,600. What is 8 times minus X?
minus 8 x
minus 8x equals 2 to 40. Okay. So first let's combine like terms. So that's 12x minus 8x.
4x.
Right, so we have 4x plus 1600 equals 2240. Alright, now we need to get rid of the 1600, right? So subtract 1600 from both sides. Then we get 4x equals whatever this is, minus 1600.
600.
So 40 comes down, right?
Yeah.
40. This one becomes a 1. 12 minus 6 is 6. Yep, 640. So 6x equals 640. Divide each side by 4. And we get x equals, what's 640 divided by 4?
No.
160.
160.
160. Right? That was the question, right? How many adult tickets were sold? 160. Right? 160 adult tickets sold. It's a bit complex, but I want you to try this practice problems. You'll figure them out. I'm going to do one more thing with us because I want to give you a little more practice. This next lesson is not too hard. Just the last bit. Yeah, you know, we don't have time. I want to make sure we do this properly. So let's just finish there. I'll give you some Khan Academy extra word problems, and I suggest you practice with them because word problems is something you just need to practice. Okay? So have a good week. I won't try to push inequalities. Better to learn it properly. So your homework is this one here, page 357. And I think I'll try to give you some extra homework on WhatsApp as well. Yeah. Extra. I think you got extra work on this. Thank you. Whoever thanks your teacher for more word problems.
Because, this word problems
Yeah.
is the real math that you are studying actually.
It is.
So unless
So like that kind of a problem we had as the tickets, that's like real life algebra.
yeah.
Yeah. Yeah. So practice, and I'll go over them more next week. But so good luck. Work hard. You guys can help each other too if you want.
Not mine.